everyone, welcome back to my channel with another interesting topic. Yes, today let us discuss on restriction enzymes. So let us know what are these restriction enzymes. This is very important because these restriction enzymes play a very significant role in recombinant DNA technology. Without this, nothing is possible. So let us learn about restriction enzymes. So let us see what are these restriction enzymes, their types and where they act upon, and what are the examples and things like that. Okay? Yes, coming to the restriction enzymes, what are these? Restriction enzymes, these are just for nothing but they are proteins that recognize a specific short nucleotide sequence and cuts the double-stranded DNA molecule only at a specific site known as restriction recognition sites. So these are specific sites. Only at that particular site these restriction enzymes will act upon and cleave the DNA molecule. Hence they are called as molecular scissors. So restriction enzymes are also known as molecular scissors. Okay? Yes. The another definition is that the restriction enzymes, they recognize short DNA sequences and cleave the double-stranded DNA at specific sites within or adjacent to these sequences. So let us see how it takes place and things like that. It was discovered by Nathan Arbor and Smith in the year 1970s. So these restriction enzymes, we need to know about the type of cuts. Okay, this restriction enzymes, it produces two types of cuts. One is the staggered cuts or cohesive cuts, also known as sticky end cuts, and the other one is known as the blunt end cuts. So these are the cuts, how they act upon DNA molecule. When they act on the DNA molecule, they cut the DNA there are two types of cuts. One is called as the sticky end cuts and the other one is called as the blunt end cuts. So sticky end cuts, there are other names known as staggered cuts or cohesive cuts. Okay, the other one is the blunt end cuts. So these are the cuts where they make. So there are approximately 3000 restriction enzymes recognizing over 230 different DNA sequences have been discovered. So let us see. In order to understand the role of action of these restriction enzymes, we need to know what are these palindromic sequence or what are these palindromes. So palindromes are the sequences which read the same on both the directions. Palindromic sequences. So palindromic sequences, there are two types of palindromic sequences occurring here. So I will be uploading PowerPoint presentations also, that is with pictures, so that in that you can understand still more better. So this is the theory class type. Okay? Yes. Okay, palindromes means it occurs on the opposite strands of the same section of the DNA helix. So this serves as a target. So there are two types. One is known as the inverted repeats. Means the DNA in the DNA strand, one strand on the top and the other strand on the bottom, like inverted repeats. Other one is called as the mirror image, like it blunt end cuts, it happens. So there are two types. One is called as the inverted repeats and the other one is like a mirror image cut. So inverted repeat means two different segments of the double helix read the same but in opposite direction. One at the top, another at the bottom. The other type is that it is like a mirror image. So refer my PowerPoint presentations also so that you can understand with the figures. Okay? Yes. Now coming to the type of, let us see what are the examples of these restriction enzymes. Like they are usually isolated from bacteria. So let us see the examples of restriction enzymes. The most common one is the EcoR1, which is isolated from the Escherichia coli, and the base sequence which identifies is EcoR1 identifies is that GAATTC. That is the specific sequence known as the restriction site or restriction recognition site. That is the where this EcoR1 restriction enzyme acts upon the DNA molecule, in turn forming sticky end cuts. EcoR1 always forms sticky end cuts. Okay, next coming to BAMH1. It was isolated from Bacillus amyloliquefaciens, and the sequence which acts on this BAMH1 acts on is that GGATCC. So let me repeat. BAMH1, the sequence is GGATCC. EcoR1 GAATTC. Okay, like that. Okay. Next is HIND3. So HIND3, it was isolated from Haemophilus influenzae, and the sequence which identifies is that is the restriction site. The sequence which HIND3 acts upon, that sequence is that AAGCTT. That is AAGCTT, both the directions. So these are the types. Okay. Now restriction types, there are 3 types. Type 1, type 2 and type 3. 1 and 3 are not that significant in recombinant DNA technology. But the most significant one in recombinant DNA technology is the type 2 restriction enzymes. So type 2 restriction enzyme plays a very important tool in the recombinant DNA technology. So they are the very important tool in the gene cloning processes. These are very simplest. The enzyme is made up of 2 identical subunits. It requires magnesium ions for its action. So these are about restriction enzymes. It plays a very important role in recombinant DNA technology. Okay then. Take care. Bye-bye.